Hello and welcome to the Automotive Diagnosis YouTube channel. In this video, I will show you how to test different types of ignition coils. Please stay with us until the end of the video and keep supporting us by sharing the video and subscribing the channel. In this video, I will show you how to test waste spark coil pack. Coil on plug with 2 wires. Coil on plug with 3 wires. Coil on plug with 4 wires. And how to diagnose the ignition system using a waveform. Let's start by talking about the waste spark coil pack. Here is the wasted spark ignition coil pack. This coil packs fire the cylinders 1 and 4. And this one fires cylinders 2 and 3. The first coil pack provides the spark voltage to cylinder 1 and 4 through these high-tension cables. And you see the other high-tension cables between the second coil pack and cylinders 2 and 3. Waste spark coil pack uses 2 coil packs to fire 4 cylinders. Or 3 coil packs for 6 cylinders. Here you see the coil packs for a 4-cylinder engine. As you see, ignition coil 1 is to fire cylinder 1 and 4. And ignition coil 2 is to fire the cylinder 2 and 3. It means each ignition coil fires 2 cylinders simultaneously. So when engine is running, each coil gets the power supply from the main relay, which is battery voltage. And ECM controls the primary coil control line. As soon as ECM interrupts the ground, magnetic field in the primary coil will collapse and it will induce the high voltage in the secondary coil, causing the spark at 2 cylinders at the same time. Obviously one of these 2 cylinders is at the end of the compression stroke, which will use the spark to make the combustion happen. But the other one will be at the end of the exhaust, so the spark will be wasted. That's why this ignition system is called waste spark. For testing the primary coil internal resistance, using a multimeter, check the resistance as shown here. Normally these coil packs have 3 pin in the connector. 1 common power and 2 individual ground for primary coils. And here I show you how to check the primary and secondary coil resistance using a multimeter. How to check the primary winding resistance on the wasted spark coil pack. And how to check the secondary winding resistance on the wasted spark coil pack. There is another kind of waste spark which has been used on many models on Toyota. In this kind of waste spark coil pack that is very similar to the coil on plug on the shape, ECM uses 3 ignition coils to ignite 6 spark plugs. Each ignition coil fires 2 cylinders simultaneously. Cylinders number 1 and 4 fire together. 2 and 5 fire together, and 3 and 6 fire together. One ignition coil is mounted on top of spark plug on cylinder number 1, and at the same time fires cylinder 4 with the high tension cable going to cylinder number 4 spark plug. One ignition coil is mounted on top of spark plug on cylinder number 3 with spark plug wire going to cylinder number 6 spark plug. And the same story for cylinder 5 and 2. Here I show you how to check the primary and secondary winding resistance. For the primary winding, measure the resistance by touching the 2 pins in the ignition coil connector and compare it with the specifications. And for the secondary winding, one prob of the multimeter must be at the spark plug terminal and the other one at the high tension cable terminal. Measure the resistance and compare it with the specification in the workshop manual. Let's talk about the 2-wire coil unplug ignition coil. Before doing anything, it is very important to review the ignition coil wiring diagram. As soon as you turn the ignition switch to on position, power supply will be provided on ignition coils via engine main relay, so you must have battery voltage on that pin. There is also ignition coil fuse to provide this power supply. Also, ignition coil is controlled by PCM using the other wire that is called control line. When engine is running, according to the engine firing order, PCM will activate the control line, so primary coil will be activated and there will a magnetic field around the primary coil. As soon as PCM cuts the control line, magnetic field in primary circuit will collapse and it will induce a high voltage in secondary coil that must be used in spark plug to ignite the air-fuel mixture inside the cylinder. First step for checking the ignition coil is to check the power supply at the ignition coil connector. Turn the ignition switch to on position and measure the supply voltage, which should be battery voltage. If there is not any power on all ignition coils, check the ignition coil fuse, which is normally in the engine fuse box. Otherwise, check the wiring. If power supply is correct, to perform the next test, turn the ignition switch off, disconnect the battery negative terminal and disconnect the PCM connectors for checking the wiring. When both PCM and ignition coil connectors are disconnected, check the continuity between the power and control line. There should not be any continuity in this case. If you see the continuity, you must check the wiring to find the short circuit. Now it's time to check the short to ground in the control line. When both connectors are disconnected, check the continuity between the control line and the good ground. You should not have this continuity. If there is a continuity between the control line and the ground, it means that the control line is shorted to the ground. The ignition malfunction could be for an open circuit on the control line. For testing the open circuit, test how much resistance there is in control line by using a multimeter. Your measurement must be less than 1 ohm. If there is nothing wrong with the wiring, remove the ignition coil and test the primary coil internal resistance as shown here. Check the resistance using a multimeter and make sure you got less than 1 ohm resistance in primary winding. Also check the secondary coil internal resistance as shown here. And now let's have a look at the coil on-plug ignition coil that has 3 wires. As you see on the 3 pins ignition coil, there are 3 pins in the connector. Power supply, which is battery voltage. Full-time ground, and triggering signal, which is connected to the engine ECM. If any one of these 3 wires is faulty, the spark will not happen. One of the major differences of this type of coil on-plug ignition system is that it does not receive a switching signal at all. It receives a triggering signal instead. In this type, the ignition control module is located inside the coil on-plug ignition coil itself. In fact, it is a transistor that provides the ignition control module function. Thus, the triggering signal is the signal that tells this transistor the exact time to make the ignition coil spark. This signal can be tested by 2 methods. One is by using a multimeter that's capable of reading Hertz frequency. And the other is using an oscilloscope. The other major difference in this type of coil on-plug ignition coil is that one of the 3 wires is a full-time ground circuit. It means that this circuit is not interrupted, opened, by any ignition control module like in a conventional ignition coil. But it is connected directly to the ground. Because this coil has the ignition module integrated into the coil itself. So, this full-time ground wire is for the transistor, ignition module, itself. So for testing this ignition coil, you can test the power supply, which is battery voltage. Test the ground pin using a multimeter. And test the triggering signal. This signal cannot be tested with an LED or a test light. Only an oscilloscope or a digital multimeter, with the capability of reading Hertz frequency, can be used. Normally when you are testing the triggering signal, ignition coil connector must be connected, then you must backprobe the multimeter, then start the engine and check the hertz frequency on the multimeter. You should see fluctuating value between 30 to 60 hertz. Measure the power supply on the 3-wire ignition coil as shown here. And you need to check the full-time ground as well. Coil unplug ignition coils with 4 wires. As you see on the 4-wire ignition coil, there are 4 pins in the connector. Power supply, which is battery voltage. Full-time ground. Triggering signal, which is connected to the engine ECM, and the ignition feedback signal. If any one of these 4 wires is faulty, spark will not happen. For testing this kind of ignition coils, with 4 wires in the connector, you must know the differences between this type and the previous ones. First of all, as usual and like all other ignition coil, there is a power supply on the coil which must give you battery voltage when ignition switch is on, or when engine is running. So, check the voltage on that pin using a multimeter. If you don't have the battery voltage on all ignition coils, you must check the ignition coil fuse, which is normally inside the engine fuse box. The next checkpoint is the full-time ground, which is exactly like the 3-wire coil and must be checked by a multimeter. The 3rd wire, which is IGT, is in fact ignition coil trigger, and again like the 3-pin ignition coil, this wire sends the triggering signal from the ECM to the ignition coil module, which is located inside the ignition coil. If this signal does not reach to the ignition coil, it will not work, so you must test the triggering signal by using a multimeter that's capable of reading hertz frequency, or by using an oscilloscope. If you don't have the triggering signal on this wire, you have to remove the ignition coil and ECM connector to test the open circuit or short to ground on that wire. For more details on how to test the open circuit or short to ground, watch the diagnostic procedure for a coil unplug with 2-wire in this video. But the last wire is IGF, which stands for ignition feedback. This wire is actually the ignition confirmation signal from the ignition coil to the ECM. Anytime that the voltage spike happens in the secondary winding, a feedback signal will be generated to inform the ECM about the ignition coil operation. If this signal does not reach to the ECM, misfire fault code and ignition coil fault code will be set. Here I'm showing you how to check the power supply on a 4-wire ignition coil. And to check the full-time ground, find the relevant pin and check the continuity between the ground pin and a good ground. You must have the continuity in this test. And finally, how to diagnose the ignition system using the waveform. Before removing the ignition coils, you can check the waveform of them to see if they work correctly. Also, you can get some more information through the waveform. To have this waveform, you must be using an oscilloscope. And you can only get the waveform from the primary coil circuit and on the control line as shown in here. Here you can see an explanation of an ignition coil waveform. Dwell time is when control line is connected, and primary coil is creating magnetic field. Peak voltage is the increased voltage on primary coil after collapsing the magnetic field. And spark duration is the time that spark is happening. And you can see a comparison between two cases of ignition coil waveforms. In left case, discharge voltage is too low, so wide spark plug gap and lean air fuel mixture could be the cause. And the right case has got a long spark duration that could be from narrow spark plug gap or rich air fuel mixture. Before having a look at a couple of case studies, check this waveform that shows you a normal operation of the ignition system. Primary coil peak voltage is at 176 volt. And spark duration is 1.32 millisecond. This waveform shows a case which spark duration is short, which is caused by a wide spark plug gap. As you see, primary coil peak voltage is at 170 volt. And spark duration is 1.00 millisecond, that is much shorter than the normal spark duration. And in another waveform, you see long spark duration that is caused by a narrow spark plug gap. As you see, primary coil peak voltage is at 160 volt. And spark duration is 1.84 millisecond, that is much longer than the normal spark duration. And in another case, you see a very short spark duration which is caused by a defected spark plug tip. As you see, primary coil peak voltage is at 328 volt. And spark duration is 0.46 millisecond, that is very much shorter than the normal spark duration. Thank you again for watching this video and for supporting us by subscribing the channel and sharing this video.